In this part of the course, we're going to explore how to read chemical formulae. It's important to be aware that symbols only apply to the periodic table. We've looked at that in one of the previous sections. A formula is used to describe a substance in real life. The plural of formula is formulae. Notice the difference in spelling. Here is an example of a formula. So H2O, obviously water. So notice that we've got a capital H and a capital O for hydrogen and oxygen respectively. And there's a subscript 2. Now the word subscript means that it sits below the line. Okay. Now this formula tells us that H2O contains 2 hydrogen atoms and 1 oxygen atom. In the following examples, I suggest pausing the video and trying to complete the sentences yourself. The formula for methane is shown above, and this would be pronounced CH4. This contains 1 carbon atom and 4 hydrogen atoms. That is what the formula means. Notice that there's no need to have a 1 in the formula. So in the same way, I would say that I have an apple. There's no need to say I have 1 apple. When you have 1 of something, there's no need to use the number 1. The formula for ammonia is shown above, and this would be pronounced NH3. This contains 1 nitrogen atom and 3 hydrogen atoms. Once again, notice that there's no need to include the number 1 in the chemical formula. The formula for sulfuric acid is shown. This would be pronounced H2SO4. This contains 2 hydrogen atoms, 1 sulfur atom, and 4 oxygen atoms. Finally, a more complicated example. The formula for sugar is shown. This contains 12 carbon atoms, 22 hydrogen atoms, and 11 oxygen atoms. Now, hopefully from those examples, you should be able to see that you can use the same method for any type of chemical formula. In this video, we will explore chemical formula involving prefixes. A prefix is a letter or group of letters that appear before a word. You can work out the formula of certain compounds if they contain one of the following prefixes. Mono means 1, di, 2, tri, 3, tetra, 4, penta, 5, and hexa, 6. In chemistry, we do not normally need to consider more than 6. Notice that most of these prefixes are familiar from everyday life. For example, a tricycle with the prefix tri has 3 wheels. Let's look at carbon monoxide. This name literally means 1 carbon and 1 oxygen. The formula is therefore CO. Notice that both letters are capital. In the second example, we will consider sulfur hexafluoride. This name literally means 1 sulfur and 6 fluorines, hexa being the prefix meaning 6. The formula is therefore SF6. Notice that the 6 is written below the line as a subscript. Finally, we will look at a more complicated example. Diphosphorus pentoxide. This name literally means 2 phosphorus atoms and 5 oxygen atoms. The formula is therefore P2O5. If you would like to practice these types of formulae further, a practice sheet with answers is given at the bottom of this page. In this video, we are going to look at understanding charges. When working out chemical formulae, it is convenient to assign a number to each element called a charge. In this course, we are going to keep things as simple as possible. You do not need to know where these charges come from, you just need to remember them. The theoretical basis behind this will become clear if you decide to study chemistry at a more advanced level. If you look at the periodic table on the screen, the charges are now shown in red. Notice that each charge has either a plus or a minus sign and a number. Again, in this course, we're going to stick to keeping things as simple as possible. When you are working out a chemical formula, you do not need to know what the sign is, so we're not going to remember them. Therefore, these are the charges that you need to remember. Notice the symmetry. They go 1, 2, 3, 4, and then they go back down 3, 2, and 1. Each number corresponds to all of the elements below it in the column. So if you look at the number 1 on the left hand side, that charge is associated with hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. We would say that the charge of any one of those elements is 1. There are 3 more things we need to quickly point out. You will have noticed that we have not assigned a charge to this column on the right hand side. These elements are called the noble gases. They do not form compounds and therefore do not have formulae. Therefore there is no charge, so don't worry about them. This group of elements in the middle of the periodic table are called the transition metals. We're going to look at those in the next activity, so don't worry about them for now. The elements in the island below the periodic table are called the lanthanides and actinides. Again, we're not going to look at them in this course. You're welcome to look at them if you want to study chemistry at a more advanced level. Let's take a look at an example. What is the charge of sodium? Ignoring the sign. So the first stage is to take a copy of our periodic table, and this is the same one that we've been using throughout this course, and to add the charges to each of these columns. Now, if you've printed out a copy of your periodic table, I recommend writing these charges above each of the columns. The next step is to find where sodium is on the periodic table. And there is sodium shown in red. You can see that it's in the first column, and if you go up to the top, you can see the charge is 1, and therefore the charge of sodium is 1. Here's another example. What is the charge of nitrogen? So again, we have the charges written at the top of the periodic table. We find nitrogen, shown in red, and you can see if you go up to the top of nitrogen's column, we have the number 3. Therefore, the charge of nitrogen is 3. Here's another example. What is the charge of bromine? Same as before, we put the charges at the top, we find bromine, and we go all the way up to the top of the column, and you can see the charge of bromine is 1. A final example. What is the charge of lead? You might want to pause the video at this point and see if you can work this out yourself. Again, we write the charges at the top of each column. We identify where lead sits in the periodic table. There it is in red. And if we go all the way up to the top of the column, you can see that we have the number 4, and therefore the charge of lead is 4. If you would like more practice assigning charges to elements, I suggest doing the worksheet included at the bottom of this page. In a previous activity, we explored how to write chemical formulae that contain prefixes. In this video, we will look at writing simple formulae in general. We have seen that every element has a number associated with it called a charge. We also saw that we can keep things simple by ignoring the sign of this charge. Here is a summary of what we saw in the previous activity. To write a formula, always use the SCSS method. SCSS is an initialism for the following. The S stands for symbol, the C for charge, remember to ignore the sign, the S for swap, and the final S stands for simplify. We will now look at some examples to see how to use this in practice. Example 1. What is the formula for magnesium chloride? Notice that the name of this chemical does not contain a prefix, therefore we have to use the SCSS method. We start by writing the letters SCSS in a column. The first S stands for symbol. We look at the periodic table, we can see the symbol for magnesium is Mg and for chlorine is Cl. Remember to be careful with the capital and lowercase letters. The C stands for charge. We looked at this in the previous activity. You should be able to see that the charge of magnesium is 2 and chlorine is 1. Remember, we don't need the sign anywhere in this course. The S stands for swap, and we literally do just that. We swap the numbers between the columns. The final S stands for simplify. Now the numbers 1 and 2 do not share a common factor, therefore we cannot simplify them. We just leave them as 1 and 2. We will see an example later on in this video where simplification will actually take place. The final thing we need to do is write out the formula, which is here. Notice that Mg, as there is only one of them, is just written as the symbol Mg. There is no need to put the number 1. The 2 for the chlorine goes after it as a subscript, as per usual. Example 2. Write the formula for sodium chloride. Again, we start with SCSS. The first S from symbols, look at the periodic table. The C is for the charges, 1 and 1 in this case. We swap the numbers round, and finally we simplify them. Again, it's not possible for 1 and 1 to be simplified using a common factor. Therefore, the formula for sodium chloride is NaCl. Example 3. What is the formula for aluminium oxide? Now this one's slightly more complicated, and if you want to challenge yourself, you can pause the video at this point. Once again, we start by writing out SCSS. The first S stands for symbols, the C for charge, the S for swap, and the final S for simplify. And again, the numbers 2 and 3 do not share a common factor, and therefore we cannot simplify them. And so the final answer is Al2O3. Example 4. Write the formula for magnesium oxide. Again, slightly more complicated. If you want to challenge, practice, check your understanding, pause the video at this point. As usual, SCSS is the starting point. The S for symbols, the C for charges, swap the two numbers between the columns, and the final S stands for simplify. Now in this case, because we have a 2 in both columns, they have a common factor, and so we can divide them both by 2. So we get 1 and 1. That's what we mean by simplify. And the final answer, MgO. Example 5. Write the formula for silicon oxide. Again, pause the video if you want to test yourself at this point. As usual, SCSS, symbols, charges, swap, and again, because we have 2 and 4, we can simplify because they both can be divided by 2. They both share 2 as a common factor. Therefore, we get 1 and 2 once simplified. So the formula for silicon oxide is SiO2. In this section of the course, we're going to look at writing advanced formulae. On the screen in front of you, there is a summary of some of the things we have covered already. We have the periodic table that we've been using throughout the course. We have the charges without the signs at the top, the noble gases, the lanthanides and actinides, and the transition metals. From what we have already looked at, you are now in a position where you can quickly understand almost any chemical formula. And to prove this, we are going to look at the transition metals. The charge of a transition metal will always be given to you in the form of a Roman numeral. Now, the transition metals are quite special because depending on circumstances, each one of them can have a different charge. So the charge must always be given to you in the name. And a Roman numeral, which you might already know, is just an old way of writing certain numbers. Okay, so I means 1, II, 2, III, 3, I followed by a V is 4, V is 5, and then VI is 6. Example 1. Write the formula for titanium 4 oxide. The method is very similar to what we looked at before. SCSS. The first S stands for symbols. The C stands for charges. Now, in the name, you can see they've given us the charge of the titanium. And from before, we know that the charge of oxygen is 2. This S stands for swap, so we swap the numbers between the columns. And finally, to simplify this, we can see they both share a common factor. They both divide by the number 2. So we can write a 1 and a 2 in those columns. So the formula for titanium 4 oxide is TiO2. Example 2. Write the formula for iron 3 chloride. Once again, SCSS, symbols, charges, and remember III is the Roman numeral for 3. Swap them between the columns, and we can see that 1 and 3 do not share a common factor. Therefore, the formula for iron 3 chloride is FeCl3. Example 3. Write the formula for iron 2 oxide. Again, SCSS, symbols, charges, swap, and we can see that they both share a common factor of 2. They both divide by 2, so we have 1 and 1. So the final answer is FeO. Example 4. Write the formula for gold 3 oxide. At this point, you may wish to pause the video and try this for yourself. The same routine as usual. SCSS, symbols, charges, swap, and as they don't contain a common factor, we can't simplify them any further. So the formula for gold 3 oxide is Au2O3.